Hi good people, Titus here for part 2 of our Asteroids mini-series, and in this video, we'll tackle creating our movement code for our spaceship. Let's not waste any time and jump right into it. Okay, I'm going to go into the Blender folder, and we're going to create a new folder. We'll just call it Ship. And then I created a simple static mesh in Blender of a spaceship with some material slots. So I'm just going to drag that into Unreal. I'm going to leave the defaults and import it all. It does not have a skeleton on it, so it's going to be a simple import. I'm then going to go to Blueprints, and we're going to create the Blueprint actor. That's going to be our player character. So right click, Blueprint class. We're actually going to choose the type Pawn. We'll call it BP_ship. Open that up here, and let's dock it in our main window. The first thing I'm going to add is a collider, or a maybe search collision. We have sphere, capsule, and box. This is a simple project, so I'm just going to do a simple box collision, and I'll just name it collider. Now the collider is going to have a few different settings changes. The first one being that we want to simulate physics. And then we want to disable gravity, so we'll uncheck that there. And then there's a constraints option. We want to expand this out. Now, we're actually going to be moving the collider around, and we're just going to attach our static mesh inside the collider, because the collider can pick up collisions, so when you hit an asteroid and stuff. So we'll do all the movement code just through the collider, and the static mesh will just kind of be floating on the inside, just following it along, so it'll look like the ship's actually moving around. This is going to be a top-down game, so because Asteroids is typically a 2D game, because we're working in 3D, we'll just put the camera top-down to kind of make it look like it's basically a 2D Asteroids game. So because of that, I'm not going to be rotating on the pitch or the roll, which is the X and Y. I'm only going to be rotating the yaw, which is the Z-axis. So we can lock these two axes here. And then the other thing is, because we're simulating physics, the collision preset for overlap all dynamic will not work. There's a few of them that'll work, but we're just going to set it to pawn, and that should be good enough for us. Now the next thing we can add is our static mesh, so I can do Control Spacebar, go to my Blender folder, into Ship. I'm just going to highlight the actual mesh, and then hit Add Static Mesh. And it'll kind of add it up over here. Now, I'm okay with the name there, but the scale's a little big, so I'm actually going to scale it down to maybe 0.1. So it's a lot smaller. And that looks pretty okay. Let's go back to the actual collider, and we got to set the constraints. Now you'll notice with Unreal Engine, it uses X forward and Z up. So the X is the red arrow. So we're going to want to rotate our ship here. Let's go ahead and set our box extent. The numbers I found for my static mesh are going to be 160 by 50 by 75. So somewhere right around there. And then I'm going to go to the ship here, and then I'm just going to, press E, and then rotate it around 90 degrees, and then I'm actually going to scale it maybe 0.2 to make it a little bit bigger, and then I'll drag it back a bit, and maybe a little bit more, and that seems pretty okay. Okay. So now what we can do is we can compile and save this, and we can actually go into your project settings. So edit, project settings, and under maps and modes, there's a selected game mode. I'm using the third person template, so you'll want to change whatever mode you're in. You want to change the default pawn class to be your new BP_ship or whatever you named it. If you don't see the name here, it's because you probably did a blueprint actor. This will only pick up pawns and characters. So make sure you choose, for this example, I'm going to be using a pawn, but either one. I'll switch it to ship there. And now if I hit play, it actually brings us into the level, but I can't move around because we have no movement code, and the camera looks a little funky. Now we're going to be using a level camera, so we're not going to be attaching a camera to the actual pawn actor. So let's go ahead and set up the level real quick. We can quickly add a player start. We'll drag that in. I'm just going to set that to 0, 0, 0. And then the next thing I'll want to do is I'm going to add a camera actor. So drag that in the scene. And I'm going to put that at 0, 0, 0. Actually, we'll do 0, 0, 2000. And I'm actually going to come up here. And I'm going to rotate it and pitch it down 90 degrees. So it's looking down here. And then let's take a look at some of the camera settings we have. I think constraint aspect ratio, I'm going to uncheck that for now. We may change that later on. And we're going to want to add auto activate for player. We'll set to player 0, so it automatically possesses, so we can actually see. And then if you wanted to, you can go down and do some post-process effects related to like lens flare and all sorts of stuff, but we'll worry about that maybe later. But if we hit play now, we can see the ship. Now we can't move around still because we got no movement code, and the ship is a little dark. So to fix the darkness issue, we just need to add a light. So we can go to our lights and just add a simple directional light. We will put that at 0, 0, 0, world origin. I'm going to set the intensity to just be 1. And I think that should be bright enough in the scene where you can kind of get an idea of what's going on. So it looks pretty good so far. But now we can begin to set up the movement code. In order to get the movement code working, we're going to need input. So let's actually create an input folder. So we'll go to content, we'll do a new folder, and we'll just call it input. Our input's going to have two things. It's going to have a input mapping context, so we'll add that. So IMC my controller, or my controls, whatever you want to name it. And then it has input actions. So we'll do an input action. First one we're going to have, we'll call it maybe thrusters or thrust. And then the next one we'll do is spin. Because basically in Asteroids, I think you just have a single force on the back, and then you just use your your controller to rotate the ship around, and it just forces whatever direction you're going. So nothing too crazy here. So let's open the input actions first. And the default actions come in as digital booleans, so basically buttons on off. This one we're actually going to set it to a 2D vector. And that's pretty much it. So we can close out of that one. And we'll do the same thing for the thrust. It'll be a 2D vector. The actual IMC is going to basically be where most of the setup is. So under mappings, you'll hit the little plus sign and then expand it out. And then you'll see all the different mappings. I have some of the third-person template mappings in here as well. We're going to add thrust and spin. And we can expand these out here. For the actual thrust, I'm going to add a gamepad. I'll do the left thumbstick 2D, and then I'm going to add another one. And I'm just going to hit the little button, and I think the W key for going forward is a good one. And then I think the up arrow will probably be another good one. And then for the game pads, you probably want to add a modifier, and you can add a dead zone. It's probably pretty good to add for game pads, but I think that's good. For the thrust, the spin is actually pretty simple. We're just going to add, of course, the game pad. I'll do the right thumbstick 2D, and then you can add a modifier. We'll do a dead zone, and then we're going to add a mouse XY 2D axis, and then that's pretty much the controller setup. So there's nothing too crazy with that one. So we can close out of that. Now let's set up the actual movement code. So we can get rid of the tick and the begin overlap. We'll worry about that later. On the begin play, we'll want to do a cast to the player controller. Off the object, we'll want to do a get controller. And as the player controller, you want to do the get enhanced input local player subsystem. And then we can come into an is valid check. Should be this one, I believe. We'll hook up our input here. And then we can come off the blue pin and do a add mapping context for our input node. Off the is valid check, we could plug into here. The mapping context, that's going to be our controller scheme that we made. So we did the my controller. Defaults are fine, and that should be good for the begin play for now. And that'll unlock the ability to actually trigger our input actions. So let's actually do that now. So if we run a search for enhanced input action, you'll see we have thrust and spin right here. So we'll do thrust first. And then we can come into a add impulse. And then there's a few references. Add impulse with the collider, because remember we're just going to be moving the collider around. The static mesh will follow the collider because it's a child of it. So that seems to be the easiest way to do this. Move this out of the way. Hook up the triggered here. We need to figure out an impulse so we can get our collider. And then we can come into a get world rotation. And then off the world rotation, you can get the forward vector. And off the forward vector, we can multiply into some value. And then that'll be our impulse or the direction that we move. So we got to figure out how to get the value when we multiply. So to do it, we can just create a variable. Maybe we'll just call it speed. And we can actually use a float. So we'll set it to a float, compile and save. I'm going to start off with maybe something small like 5. And then we can just drag this speed value into this multiplication value. And then we'll add this to the impulse. And you're going to set it as a velocity change. If we compile, that should, we can't spin or we can't rotate, but we should be able to kind of move. So you can see there. And we go off screen. Let's do the actual rotation now. So come down here, more of the same. So we'll do an enhanced input action, and we have the spin. This time we'll want to right click on the action value and actually split it because we're going to use this X and Y. We're going to come into an add relative rotation. And if you remember, we're moving the collider. So we're going to reference the collider or whatever collision system you're using. Now we need a rotation. Because this is a top-down game, we're not rotating on the pitch, we're not rotating on the roll, we are only rotating on the yaw, because it's top-down. So we can right-click and split this, and we don't need to worry about the X and Y values. We can then take the X and Y of the controller into an add node, and you just add these values together and plug them in to the Z value. And that'll be good enough for your gamepad and your mouse to actually rotate around. Like so. And with the arrow keys or the W keys, you can begin to kind of fly around like so. Alright. Ship's a little bland though, so we can see if we can maybe add some material slots to make it pop a little bit. Let's go to our content folder. We'll create a new folder and we'll call it materials. Right click, create a new material, call it m_ebase for emission. And then my static mesh has a few material slots, so I'm going to make another one called m_taillight. This one you probably won't have to follow along with, but it's more for fun. For the emission base, I'm going to select this from a default lit to an unlit. I'm going to hold 3, click into the graph, right click, convert that to a parameter, call it color. I'm going to press M, click into the graph, hook this into here, and I'm going to hold S, click in the graph. I'm going to call this power. I'm going to set the default to be 100. Drag this into here and plug this into here. And that's going to be our emission. For the tail light, I'm just going to select this to be unlit. And then I'm going to select a 3. I'm just going to actually set the color manually. I'm going to do like maybe a blue or something, or a cyan. And then we're going to come into a multiply node. And then for this one, we're actually going to be adjusting this value through code. So I need a parameter value, which we created a material parameter collection. So we can actually go back into that. And I'm going to add another scalar parameter. So let's add one. I think for the default, I'll just leave it at 1. And I call this the tail light. And then save. And then I can do control spacebar. I can drag that material collection in here. I can pick which one. I want the tail light. Drag it into here. Plug that in emission. And then I'm cooking with gas with that. Alright, so now for the emission base, I want a couple different colors. So you can just, on the base, you can right click and create a material instance. I'm going to call this mi_engine. Create another one. I'm going to call this electric 1. And I'll call this electric 2. And then I can open these instances. And I can just check color and power. This one's my engine. I think my engine should be like an orange. So I think that looks good. And then electric 1, I'm gonna make this maybe some kind of blue. And this one I'll maybe make some kind of purple. Something like that. Alright, so if we go back to the ship, I can select the static mesh, and you see I have all these different material slots from Blender. So I can go into the materials, select engine. I have an engine slot here, so I can plug that in there. And now we have some engine lights. Electric 1, I can plug that in here. And then electric 2, we can plug that in here. And then the tail light I can plug in here. And now we get something a little more vibrant, a little more interesting. Which looks pretty good. For the tail light, I kind of want it to flash. So the way I can do that is on the begin play of the ship, I can come into a timeline. And then from that timeline, I can set the scalar parameter value. And if you remember, we created our parameter collection with a new parameter value called tail light. And it takes in just a parameter number, which is basically going to reference the power or the intensity that it multiplies the color against. So for the timeline, we can open this up. I can add a single float track. I can call it parameter. Maybe do 4 seconds. Let's add a right click, add a keyframe. We'll do one at 0, 0. We'll do another one at 4, 0. And we'll do one in the middle at 2, maybe 10. Let's try 15. And that's gonna be the power of the brightness of the light, basically. I can right click on each keyframe and set it to auto to smooth out the graph, so it's it's an easy transition. I'm gonna set the autoplay loop to enable. Compile and save that. And then off the begin play, I can come to play from start. On the update, I can come into the scalar value and just plug the parameter into the parameter, which is what we named the item in the graph. And if I compile and save and play, we should have a flashing taillight. It like flashes every 4 seconds. It's kind of hard to see. I think the scene is probably too bright, so we maybe need to remove some of that purple and just make it more of a like a traditional black spaceship or space background. The way we did that, we handled it in the let me go to our textures, our space skybox here. So we go open this up here. We can kind of cheat. Let's just do we'll come into a multiply node early on here, and we can reduce this by 0.1 and plug this into B, which is basically going to bring more of this black. And then what we can also do is coming into the parameter collection, the scene brightness, we can reduce this to 0.1 as well. And we'll leave the star brightness, which is the white, or the whites of the image. We can leave that as full. And that way it's going to be much darker. So let's see what that looks like. So if we hit play, so now maybe we get rid of some of that purple, and then you have more of a traditional space background. As light filters in, some of the purples will come up, which doesn't look too bad. The other thing let's do is we can select our camera actor, and let's maybe bump that to 3000 on the Z. There we go. So we're a little bit further back. And let's add a Niagara system too. So let's go to our content folder. We can do a new folder, call SFX. And we will right click, create a new Niagara system. We'll use a template. The template I'm going to use is just a fountain, simple. Call it ns_engine. And first thing we want to do is get rid of gravity, so we can delete that one. The sprite render, I'm going to use my mi_engine. And then for my spawn rate, I'm going to set that to be 180. And then for my velocity, I'm going to double it. So 1000 and 1600. For my min and max. So I can save that, go back into the ship, and control spacebar, we will highlight our Niagara system, and then we'll come to the collider, we'll hit add, it'll reference the Niagara system. I can then press E to rotate, and then just rotate it 90 degrees, W, and then just shimmy it back. And then maybe I'll change my grid to 5, pop it up once, and that looks pretty good. But I don't want the thing to just play constantly, so I'm going to set the auto activate to off. We'll go in and adjust it through code. What makes the most sense is to do it off the thrust command, so we'll just move this forward. And then basically before we actually engage the thrust or move the ship, it makes sense to play the effect. So before moving the ship, we'll just call into, actually it's easier if I let's drag the engine out. And then you can just reference set active. And then you can reference deactivate. And then you can actually expand this out. So on triggered, we'll do set active and tell it to new activate. And then on completed, we'll tell it to deactivate. And then we can just plug the rest of this in here. And then I could probably move this back a bit. Something like that. So now if I did that right, you should be able to actually move your ship around. You have some pretty cool materials, and then you have some particle effects where you can actually shimmy the ship around. Alright everyone, we'll cut the video here, but I hope you found some informative value in the topics that you can take into your own projects. In the next video, we'll begin setting up the game borders, so the player is restricted to the camera view, and we'll maybe give our player the ability to fire some lasers. But as always, thanks for watching, consider subscribing, and see you on the next one.